Okay guys, so we're going to talk about types of variation, which is a little bit of a segue into how we now start to graph different things, specifically rational things. But we're going to tie in some other stuff that we've already done. So one type of variation that we have in a graph or in data is direct variation. Now, direct variation is really just a linear equation without a y-intercept. Okay, so it just looks like y equals mx, although for whatever reason they decide to call here m k. But this is really just, oh, frick me. This is not going well already. Okay, y equals k times x, where k is just your slope, your m value, which we can also call your constant of variation. It is the amount that you are consistently changing by as x changes. So some things to note about this: x and y change together. So they either go up together or down together. They do the same thing. And their constant of variation, k, can be found simply by getting k by itself, which means I need to divide both sides by x. And so to find k, your constant of variation, we're going to divide to get our direct variation constant. Okay? For example, x and y increase together, right? If we have something that says y varies directly with x, that is just code for y is going to look like k times x, some number times x. When y is 9 and x is 6, that will allow me to then find that k value. Then I can find other values, because if I have an equation, I can find other values. So then what is y when x is 20? Okay, so we start with this because we're direct. I plug in 9 for y, 6 for x, so that I can solve to find k, 9 over 6, which really reduces to 3 over 2. So my equation is y equals 3 over 2 x. As x goes up, or as y goes up, we're always increasing by 1.5. Okay, so this will allow me to then plug in 20 for x to find what y would be, and I would just cancel there and get 30. Okay. We could also represent this as a graph, like we know how to graph this because it is just a linear equation. I would plot my y-intercept at 0. Direct variation will always go through 0, your origin. And then from here I'll just go up 3 over 2. And I can also go down 3, back 2 to get a line. Okay. So pretty straightforward stuff. Another type of variation that we have that is going to be maybe new to you is inverse variation. Okay, so inverse variation looks different. It's y equals k over x. So we're not multiplying by x anymore. We are dividing by x. But this here is still like our slope-ish number. It's still called k. It's still our constant of variation. However, x and y no longer change together. They change oppositely of each other. So as x goes up, y goes down, or vice versa. So they change oppositely. And to find our k, constant of variation, so that we can write an equation and get lots of values, to get k alone, I simply am going to times by x on both sides. So x times y will get me my constant of variation here. Okay. So, for example, this is just telling me my equation is going to be inversely. So y varies inversely. It must look like y equals k over x. These two values allow me to find that k value equation for my equation, and then I can find more values once I have an equation. So we start with y equals k over x since we are inversely. I plug in 9 and 6 and times by 6 both sides so that I can find k to be 54, which then allows me to write my equation y equals 54 over x. That will help me to be able to find values of y when I know x. So since x is 20, we can plug that in. And I would probably just reduce there, like definitely 2 will go into both. Like 27 times there, 10 times there. So 2.7, or just 27 over 10. Whatever works for you. Now this is definitely something that I don't know how to graph yet. So if I think about a table of values, we want to maybe consider some positives, some negatives. So if my equation is that 54 over x, some negative values that I might pick are like -2, because 2 can go into that. I could do -1. I can't do 0. But I can do 1 and I can do 2. So if I plug those in, like here I get -27, -54, 54, and 27. And so at this, like, let's say maybe we're counting by 5s here. So -5, -10, 15, 20, 25. We're still not big enough. Let's count by 10s. 10, 20, 30, 40. There we go. Okay, so if we go -2 and then down -27, and then -1 down -54, you're kind of doing this sort of thing. And I can't be 0, and like I feel like I'll continue going up this way. But then when I'm 1, I'm all the way up at 54, so 10, 20, 30, 40, 50, and a little extra. And then 27. And so I feel like it'll continue going down, down, down like that. And so we get kind of 2 pieces of a graph here, which we'll definitely take a look at those graphs some more after we take our quiz. So don't worry too much about graphing anything yet. Okay, so then the last type of variation that we have is joint variation. So if we vary jointly, we have joint variation. That's just when we have more than one type of variation. But if it's not specified, then we just assume multiplication. So this is when we have more than 1 or 2 variables. So y equals k times x times z, where the only number being replaced, or only letter being replaced, is k, still our constant of variation, which is very different than what we're used to, because what the heck is z? And what the heck z is just another dimension. So we're not in 2 space anymore because we don't just have 2 variables. We are in 3 space. So that's kind of what this graph looks like. We got our x-axis and our y-axis flat on the plane, and then our z-axis coming up, which we don't have to graph on this, so don't freak out. Basically, if we are told that x, y, and z vary jointly, then we're going to go y equals k times x times z. And all these numbers here will allow me to solve for what k is. So we can put 10 in here, 3 in here, 4 in for z. And so then we'll have 12 times k, and divide by 12 on both sides. We'll have 10 over 12, which reduces to 5 over 6. And so our equation should look like y equals 5 over 6 xz. And then if they want me to figure out what x is when y is 20 and z is 1, I can just plug in 20 for y and 1 for z, which kind of don't need it. And to get x alone, I would multiply by the reciprocal, so 6 over 5 on both sides. And then we cancel here, and we'd just be left with x. Here are the 5 and 20, we can do that, so it's 4, so 24 is what x is. So we kind of want that and the equation as our answer. Can't really graph that, so don't worry about it too much. Let's try some out of our book. Okay. So we have direct, inverse, and joint variation. We have our formula, so y equals k times x for direct, y equals k divided by x for inverse, and joint is just when we have lots of letters. Okay, we can talk about some more features tomorrow in class, so we're going to leave that blank for now. When I'm looking at equations, I should be able to tell if I am direct, inverse, or neither, if y is by itself, and it looks like the corresponding equation. So since y is by itself, and that looks like two numbers being multiplied, or x is on top, that would be direct. Here, y is by itself. X is being multiplied, but there's also a -4, so that's kind of neither, because direct variation can't have a y-intercept, and that one does. Here we're inverse, because x is being divided. And here, y is not alone, so I need to get y alone by dividing x, which then shows me x is being divided, so we're inverse. Okay. Now when I'm looking at a table, I can tell if I'm direct, inverse, or neither by seeing what that constant of variation is. So if my constant of variation happens when I divide x and y, so like I get a constant number if I'm dividing, then I'm direct. If when I multiply the two, I get a constant, then I know I'm inverse. If I'm neither, then I'm neither. So I'm going to do two quick examples, or maybe I'm just going to do one. I'm just going to do one. So like, for example, number 7. I always start out by dividing first. So if I do y divided by x, I get 6 over 2. And it's kind of like, is that the same as 7 over 3? Is that the same as 8 over 4? And I feel like I already know my answer. This is not direct. So then I try to multiply them instead. So is 6 times 2 the same as 7 times 3? Which is the same as 8 times 4? And again, I feel like I already know my answer. Those things are not the same. So it's not inverse. So that is neither. Okay, and we can try some more of these tomorrow together in class also, if you're not quite sure. Those are more equations like the one I did on the side. So I actually want to jump down and maybe try these ones right here. And if you guys need to pause to maybe write those out. These equations are just telling me, or these words are just telling me what my equation needs to look like. So when this says that it varies jointly with all those letters, then I know I just need to say m equals k times n times p times q. And I'm not really going to be able to solve for k here because they didn't give me any letters, or numbers rather, to fill in to solve for k. So you're kind of just looking for these keywords to help you figure it out. So for number 2, x varies inversely with the cube of y. So that's interesting. So inversely means that I should divide the cube of y, which is y to the 3rd. Okay. A varies jointly with x and y. I'm like, okay, jointly, x, y. But then inversely with m, so now I need to divide m. So it's just like I divide whatever is inversely, multiply whatever is direct or joint. And so that last one is maybe one that you could try. T varies directly with u and inversely with w. We can talk more about those tomorrow too.